Hello and welcome to the Oxford MAT Livestream. My name's James and it's brilliant to have you here. If you've joined us through some sort of YouTube recommendation algorithm, then hi, great to have you with us. This is a live stream about maths. We're going to solve some maths problems and talk about problem solving. We're broadcasting live from the University of Oxford, from just my office in the maths department. And we're going to mostly be talking about maths admissions test questions for this. But with some interest in other maths questions as well. We're going to get distracted and go on some tangents as well. Hi to people watching live. You're my only way to know whether I've set things up properly. How's it going where you are? Can you hear what I'm saying? Who knows? If you've joined us from the sort of mysterious YouTube recommendation algorithm, then I need to point you to a website that we've got. The MAT Livestream website looks like this, and that's how I think most people have found us, because there's a button there to join the live stream. There's also a button where you can join a kind of live chat. The live chat is over in Slido, as Michael has just noticed in live chat. It's not on the screen, but I'm watching it on a separate device as we go through, so stuff you say in chat I can see. Slido has got the option to set your name. You don't have to set your name. You can be anonymous. You don't have to join in with the chat. You can set your name to anonymous if you like that sort of thing. Anyway, people are joining chat right now, so I'm going to say hi to a few people. Hi, Cool and Urban Miles. There are some names here I recognise from the Oxford Online Maths Club, and some other people too watching as well. Good, okay. Other things on this page that I want to draw your attention to, I guess. There's some worksheets. Unlike other projects we've done, like the Maths Club, where you sort of just turn up and see what's happening, on this one we're trying to announce in advance what we're doing, so that if you want to have a look at the material in advance, you can get going with that. Hi to some anonymous people who have just joined. They've worked out how to be anonymous on Slido. It's brilliant. Johnny's here too. Hi Johnny and Conrad. Right, good, okay. There's the link to the live stream again. This will be a table. This will be a table of live stream episodes on the page with, well, I suppose that's where the recordings will be. If you decide you don't want to watch live, or if you're watching a different time zone or something, then you can watch the recordings from there. That's also a good idea if you want to watch them at double speed, which I've been told by my students that some people like to do. I have a note about students, by the way. So I do this survey of Oxford students, and the last time I surveyed first year students, I found that more than half of them had watched this. There's a couple of hundred maths students each year at Oxford, which means that, back of the envelope calculation, there's about 100 future Oxford students watching this. Maybe that's you. There's kind of no way to know. Maybe you're one of about 100 future Oxford maths students who are watching this, either live or in the chat. The reason I mention that is, as we go through this solving maths problems together, there will be times when you feel like the cleverest person in the room, and there'll probably be times when you don't feel like the cleverest person in the room. You have absolutely no way of knowing whether you're in 100 Oxford mathematicians who are watching. There's just no way to know, and you shouldn't worry about it. We're going to do some maths. If you get the answer wrong, you get the answer right, doesn't matter. We're here to try doing maths. Good. Chat is going really well. Hi Simon. Hi Casey. I can see another anonymous person. Yes, brilliant. Someone has set their name as anonymous, which you can do. To be known as anonymous, known as unknown. Brilliant. We've got knowns, we've got unknowns, we've got known unknowns. Right, good. Also down the side here, there's an archive of previous years. If you decide that 1 week per week is too slow, and you decide that watching episodes at double speed is too slow, and you want to watch more than 1 week per week, then you could tune into a previous year. Things you might notice if you look at the archive, the colour scheme is a lot better this year. We had a revamp, and also we're rebuilding all of the problem sheets. I'm putting some more time in to revamp the problem sheets. Not that there's anything really wrong with the previous sheets, just felt like time to give them a bit of love again. You're in an odd numbered year, odd numbered years get a fresh look at the question sheets. Hi to RKN and Shamina in chat as well. Okay, what else do I want to tell you? There's also the MAT page. It's linked to from that MAT Live page. Once you get onto our website, you can probably find all of this stuff. The MAT page has got facts about the maths admissions test. That'll be relevant to some people, I guess, if you're thinking about doing the maths admissions test. Maybe that's why you're here, maybe that's how you found us. There's going to be information posted there. I can answer questions about the maths admissions test, but I'd like to, I suppose, save those for some sort of Q&A near the end, and there's some stuff that I can't say yet that's going to get announced on this page. I guess I'm pointing you to this page as maybe the best way to stay up to date with facts about the MAT, like when is it? I get distracted very easily is the thing, and if people ask me what dates the MAT is constantly in chat, I might not be able to always say. It's the 19th of October. Thanks for asking. Good, okay. MAT facts are on the website as well. Here's how this works. I've got excruciating detail on this slide, sorry. The worksheet goes on the website in advance. So if you decide that you don't want to watch the live streams, maybe you don't like the sound of my voice, or even at double speed it's no good, then you could just look at the worksheets and look at the solutions and skip the live stream entirely. Up to you. That's fine with me. You can grab the worksheets on that page. They've got some revision notes on A-level. We're going to look through them in a minute. They've got some revision questions, which are sort of somewhere between A-level and a little bit harder than A-level, some of them. And there's some MAT questions where I've written some hints as well. During the live stream, we're going to go through some of those questions, but not all of the questions. I'm going to be swayed a bit by what people in the live chat want to talk about. So if you're here live, you get the say. If you're watching live and you want us to skip a question or focus on a particular question, or if you want me to say something again, then you can ask that in live chat. You can also try the questions and talk to me about how you're doing the questions. Somebody in chat, oh my goodness, has just realised that the MAT is on their birthday, which, you know, the odds of that remote, but it's happened. I wonder if anybody else has got the same birthday. Just me. Just me says hi. Okay, so during the chat, there's live chat. I'm going to be quite swayed by the live chat. I'm going to try not to get too distracted. You can already see that I'm getting distracted by live chat. They're brilliant. And we're going to work together on some of this. The solutions get posted on the page. I would look at the hints first before looking at the solutions. That's the order I wrote them anyway. And you can skip the whole live stream if you want to. But you're here now, so there you go. If you're watching the replay and you're missing out on that kind of live interaction, you can try leaving a comment underneath. We're going to check semi-regularly, but this is sort of, you might not get a response very, very quickly. Okay, here's the question, who's this for? And someone's just asked in chat, do you have to be in year 12? I can think of several groups that this is for. Mostly I've aimed at people who are getting ready for maths at university. Not just Oxford, people who are doing maths at university. I don't really mind if you apply to Oxford or not. Obviously, if you apply to Oxford and you study here with us, that's brilliant. But in terms of this live stream, I don't really care. It doesn't matter to me. I just want to help you out. Wherever you're going to study maths at university, I think that having some time now over this summer in particular, might be helpful as you get ready for that. So I guess that target is people in like year 12 going into year 13. You've just done some exams maybe, or maybe you had no exams. Now you've got a big gap before year 13 starts and you're wondering what to do over the summer. I'm kind of aiming this at you. People who are revising the first half of A-level maths, that might be you as well. But also I've realised from doing this a few years now that we tend to get a few people who are perhaps a bit younger, people who haven't learnt A-level maths yet and are sort of sneakily trying to get ahead with maths. I see you. I had a very similar experience when I was at school, and I went to a maths club after school, and some of the older kids taught me maths, and that was brilliant. This is probably not the best way in the world to learn A-level maths, but you will see some A-level maths. You might not understand all of it, but that's part of the fun, right? So if that's you, if you're not in year 12, if you're a bit younger and you're just trying to see some maths, then hey, prepare to have maths coming out the screen. I know this is boring doing slides, but I've got to do this kind of info at the start, right? It was a specific question about the remainder theorem. The remainder theorem was removed from the syllabus in, oh gosh, quite a few years ago. So not remainder theorem for today. If you just want to see some maths, if none of that applies to you, you don't care about A-levels, you're not revising A-levels, you're not about to learn A-levels, and you're not doing maths at university, you just want to see some maths, then this is also for you. There's a reason this is just free on the internet, no sign-ups required. We want to show you some maths. I promise I'll get to some maths in a minute. Sorry, this is taking longer than I thought. Can you tell that I'm distracted and bored? I don't know, just want to do some maths. Other stuff that we've got. I'm kind of on top of that picture of the flashcards. Anyway, there are loads of past papers on the MAT website. We're going to go through all of them on the MAT live stream this year. That's in response to some feedback from our current students. Our current students said that they felt that they wanted to do all of the past papers, but the MAT Livestream only did some of them. This year, I'm doing all of them. We've started a bit earlier, so we've got more time. We're going to do all the past papers together. There are some really long videos with video solutions for recent years. Earlier on, if you're revising the topics on the syllabus, there are some flashcards to help you out with that. And like I said, we've got archives of previous years' live streams. Okay, I think it's time to look at some maths. Let's quickly check how everyone's day was. This is a poll that I like to do just to check how people were doing. If you're in Slido, I think you can now see a votey poll thing about how was your day today. People on the stream and watching back can't see it because it's not appeared on screen. Right, while that's happening, I'm going to try and use the tech setup. It's all very exciting. Everything's a different colour and everything's in a different place. So I think I can press this to show you the worksheet. There we go. Oh, that actually worked. I shouldn't be that pleased with myself for getting that to work. But there we go. We've got some math questions on the screen. But I actually want to start with the syllabus as a sensible start point. Okay, so let's go over here and set that up. How's people's days going? We've got a few votes. We've got a big chunk of 4-star votes with a little bit of 3 and a little bit of 5. Oh, someone had STEP today. Oh my goodness. So STEP is another maths test if you didn't know. 1 star day. That's not so good. I'm not sure if you voted in my poll or not. You told me in chat that you're one star, and somebody else says hello in chat. So hello. I see that as well. Right. Okay. Here's the plan. The section at the top there that says MAT syllabus is literally a copy paste of a bit of the MAT syllabus. When I was at school, I didn't really know the word syllabus, I guess. It's a thing that people who set exams have to do. The people who set the exams have to tell you what content is allowed to be on the exam. I didn't know exams really did this. I just learnt stuff in the lessons, right? And then it was in the lessons. So I guess I trusted my teachers to teach me the stuff for the exam. But for the MAT syllabus, there's a very short 1-page syllabus. I've chopped it up and put it at the top of each section so you can see what's in the sections. There's a question in chat. How do you know what's going in upcoming episodes? I put the titles of the episodes. We're working through the MAT syllabus. The MAT syllabus has got sections. This is the section on polynomials. We're going section by section. The worksheets should come out a few days before the live stream. I'm trying to stay ahead of you. Good. Right. Okay. So the MAT syllabus here says the quadratic formula, which I hope we know. I've got a revision note underneath there about what the quadratic formula is. If you're learning this for the first time, then hi. Completing the square, which I think is called different things in different places. If completing the square is called something different in where you are, then let me know when we get down there. We're going to talk about discriminants of quadratics, factorisation, and the factor theorem. But as somebody in chat's already spotted, not the remainder theorem. Okay, let's do some quick revision. So I'm going to scroll down a little bit here. There's this thing called the discriminant. It's if your quadratic is ax squared plus bx plus c, then there's this quick and easy way to tell how many real solutions it's got. You just work out b squared minus 4ac, which sounds a bit magic, but trust me, it works. If b squared minus 4ac is positive, then you get 2 real solutions. If it's negative, you get none, and if it's exactly equal to 0, then you get exactly 1 solution. Sorry, that is a very good chat post that's just come in. Anyway, uncompleting the triangle. Sorry, I have to read them out, otherwise people watching the recording don't know your hilarious joke about completing the square. Good, okay, slightly further down there, I've got this completing the square thing. I don't really know how this is taught in different places. There's a bit of a skill in actually completing the square. If I show you a quadratic, we're going to try an exercise in a little bit to try actually doing that. I don't remember the formula like that. So this thing on the screen where it says x plus b over 2 all squared plus c minus b squared over 4, I don't have that memorised in my head. I definitely don't work out c squared minus b squared, c minus b squared over 4 when I'm doing this. But I can sort of work it out as I go along. That's kind of the minus b squared over 4 there is kind of to cancel out the constant term. And yeah, chat's no longer on the screen to make more space for maths. I've also made my camera smaller. You know, it's good for my ego as well to have a little square. Good. Okay. So if you've seen that completing the square thing for the first time, you might imagine how, in practice, you could work that out. It's handy because x only appears once on the right-hand side, so it's more easy to say how that changes as x changes. It's got a big squared in it as well. I like squares; they're always greater than or equal to 0. Okay. Difference of two squares is a bit of a personal favourite. I could definitely talk about difference of two squares a bit too much. It's a handy way to factorise a particular quadratic. And more generally, we've got the factor theorem, which I always struggle with. It's this way around. If a polynomial is 0 when you put in the value of x equal to a, so you put in some number a and you get 0, that means that x minus a has to be a factor of p of x. I think it's hard to really understand that because on the one hand it seems quite obvious perhaps. Polynomials sometimes have factors, and it feels like if it's got that x minus a factor, then it's pretty obvious that if it's got that x minus a factor, then plugging in a will give you 0. And maybe it's not so obvious the other way round, and it's the other way round that's on screen right now. Let me just emphasise that a little bit. I think I can get to a split screen thing. Let's see if that works. There we go, split screen. So the fact on the screen there is that if p of a is equal to 0, then whatever the size of p of x, however many terms there are, you can divide p of x. You can do this kind of polynomial division to write it as x minus a times q of x for some polynomial q of x. I'm doing very well not to get too excited by the fact that my split screen has worked. Everybody loves difference of two squares in chat. In chat says that they used to get rewarded with sweets if they shouted difference of two squares. And people are doing variants on complete the square in chat. Good. Okay. This is slightly surprising that this thing actually works out. I suppose it means that as you start doing that kind of polynomial division, that your polynomial division works, but you don't end up with a remainder. But I'm straying a little bit into what the remainder theorem says, and the remainder theorem is not on the MAT syllabus anymore. It used to be. This is a thing about looking at past questions as well. Some of them are based on maths that isn't on the MAT syllabus anymore. If you're interested, the way that A-levels work got changed slightly, so we had to move to change with it. Okay. So I've got some advice about sketching, which is on the screen there, and an important definition, which I don't really know when you learn what the degree of a polynomial is, but the degree of a polynomial is supposed to be the highest power of x that you can see, which is a handy concept for talking about polynomials in general. Most of my advice I've realised here is about quadratics. I want to point at the factor theorem again, that it's not a fact about quadratic equations, it's a fact about polynomials in general. And yeah, Miles has spotted, sorry, my letter P's are a bit funny. It's because I did a course in fluid dynamics where we had P and rho, and I had to tell them apart. So I make sure that mine look different. There's a point in a mathematician's life where you learn a lot of the Greek alphabet, if you're not already Greek, I guess. You learn the Greek alphabet and then struggle to tell your letters apart unless you, in my case, slightly modify your handwriting. So that's why my letter P's are a bit funny, sorry. Have I told you the thing about happy and sad quadratics? I think I have. Yeah, so I use the phrase happy quadratic for ones that look like this, because it looks like a smile. I use the phrase sad quadratics for ones like this. Sometimes, and I'm struggling to get this to catch on, I think we should call cubics that look like that happy, and cubics that look like that sad. So cubics have kind of maybe 2 turning points, maybe 1 or 0, but some of them look like this. I want the ones that generally go up to be called happy, and the ones that generally go down to be called sad. But this is not standard. I think in the revision notes I've put happy and sad in. There they are, happy or sad in quote marks, like bunny quote marks, because they're not real terminology. For cubics, I'm even more wrong. For quartics, for quartics, so things with quartics have an x to the 4 term in. This looks like this. Maybe it looks a little bit more like happy and sad, or maybe you could come up with your own classification of what emoji these remind you of. Let's draw faces on them, there we go. So maybe you could have your own classification of how these things work for higher powers. Right, good. I've gone off track. Yes, people in chat are talking about minimums or maxima. You've got a couple of techniques for minima and maxima of quadratics. Let's point at a couple of them in the revision notes. So we've got this complete the square idea. That could be good. I suppose the one that I've written down there in the complete the square world hasn't got a coefficient at the front of x squared. So we do a slightly more general complete the square thing. Or we might divide through by a. People are talking about differentiating as well. We've got a future session in a few weeks' time on differentiation. We'll come back for that one. Simon says, is it okay that I watch this later? Yeah, it's fine with me, obviously. This is recorded and available on the web now. I think you can even rewind it while it's live, which is good because then you can watch it at double speed, which, again, my students tell me that they like to do. Fine with me. I watch YouTube at double speed as well. Jessamy also says you've got another strategy to try plugging in a little bit above and below to find out if it's a minimum or a maximum. So maybe people are thinking about detecting happy and sad quadratics. In fact, I think the thing that all these things have got in common on my different slightly odd cases, so the happy quadratics are the ones where a is positive, the sort of first leading coefficient, and the sad ones are the ones where a is negative. I want to extend that, I think, and again, this is not standard, but I want to extend that to things like this. So here a is 1. 1 is bigger than 0. Welcome to the Oxford MAT Livestream. So this is a positive case, and I would call that happy. But this one's kind of more sad, because I think it might be ax to the 4. I'm not actually pointing at ones that you can see. There we go, where a is negative. 1 is bigger than 0. Welcome to the Oxford MAT Livestream. Ryan confirms you can rewind it and then watch it at double speed. Good. Homework. How late do you join to rewind to the start, play it at double speed, and hit the end at the same time it finishes? Is that easy? Maybe that's easy. Right, good. Okay, I think it's time to actually do some maths. Are you ready, chat? We're going to give that a go. I'm going to go back to looking at the questions. I can fit about 10 questions on the screen. I have got on the page about 18 questions. If you're playing along at home and you've got a copy of the worksheet, which you can get from that website, then you might have preferred questions that you want us to talk about. We posted it yesterday evening in the hope that anybody would have a chance to look at it before the live stream. I guess that didn't really work. If you want to grab it now and say what you want to look at, I'm all ears. Otherwise, I'm just going to work through ones that are maybe too easy, and I might go too slowly for you. Who knows? My plan is to spend quite a bit of time on these revision questions, and then some time on some actual math questions. After this, we've got 2 long math questions that we can look at. I'm not sure if we're going to solve the long math questions entirely today. It's our first episode, but we might have a look at both of them. We're live until about 7 o'clock. Obviously, you don't have to watch the whole thing, but that's the plan. Okay. Anything you particularly want to talk about that's on the screen right now? Maybe this all looks pretty standard to you. Maybe you're really good at quadratics and things like that. I've also got quite a bit of stream lag where there's a big gap between me saying something and chat hearing it. Reese, though, has got a request for question 5. That's how I think about question 5. Just make a little note to myself. Thank you, Reese. Yeah, so 5 is a variant on question 4, but made harder because of multiple cases. And there's another vote from Conrad for question 5 as well. I think I'll do the 4 and 5 pair, because there's a point to be made there about, well, you could imagine a harder version as well, right? We're looking at A level and then a little bit beyond, and then trying to see how it goes past there. Okay, I'm going to start doing those, but I'll leave. Let's see if I can do it so that the first 5 are on the screen, something like that. Okay, so if you want to work on a different question, let me know how that goes. That first one's really evaluate P of 2. What does it mean to plug in the number 2? Okay, there's a vote for question 2 as well in chat. Yeah, question 2 is nice. I'm happy to talk about question 2 in a second. Okay, so question 4, we're asked for the values of k such that x squared minus x plus k equals 0 has exactly 2 solutions. I guess there's no point in me writing out the question because thanks to split screen technology you can see it at the top of the screen. Oh, this is great. Don't get too excited about the tech. Nobody cares about the tech. Let's work out the discriminant. It's that slightly magical thing that tells us whether this thing has got two solutions or one solution or no solutions. For A is 1, C is k. We want that to be bigger than 0 for 2 solutions, which, if I rearrange this a bit, says that k should be less than 1/4, I think. Does that make sense? Yeah, suggestion in chat as well. Brilliant. Michael's there as well. Michael, I want you to know that you posted that sensible thing in chat before I wrote it, even though I read it out after I wrote it. Anyway, never mind. It's always a good idea to check that your answer kind of makes sense. So here I could imagine this as like a quadratic, x squared minus x, which I think looks like this. And then the value of k is a translation to that graph. K translates this thing up. So if we add k, it moves that graph upwards. Moving that graph upwards has the effect that if you move it up too much, then there are no real solutions. So it kind of makes sense to me just imagining that making k negative is fine, keeping k at 0 is fine, but if you make k too positive, then you're not going to get any solutions. It's gone up off the top of the screen. Okay, so this kind of makes sense as well. This kind of lines up with roughly what I was expecting. K less than some number, turns out it's 1/4. I think that's something to do with 1/4 being the minimum value, minus 1/4 being the minimum value of that quadratic, the one I've sketched. I think it's got minimum value minus 1/4. Extension question, where's the minimum of that quadratic? Where are the roots of that quadratic? Quadratics are pretty nice, they've got a lot of symmetries. So I'm going to try and throw extension things in as well, just to keep people awake, so that even if you've done the question, you can have something else to think about. Okay, next part. 5 asks us about x to the 4 minus x squared plus k, which is the same thing, right? Except the x has been replaced by x squared. So if I do something sneaky like let u equal x squared, then I'm looking at u squared minus u plus k equals 0. And we just talked about the solutions to this equation. We just talked about whether there were 2 or not. But there's a problem because we're going to do some square root stuff. Over to chat. What effect does that have? What are the different cases that might happen? So we've kind of got a 2-step thing going on here. I've got u squared minus u plus k is 0, and I've thought a little bit about whether that's got solutions or not. I want to let u be x squared, and then talk about, I guess, x is the something like this, plus or minus square root of u, to undo that squaring. that kind of already looks like two solutions, right? If you tell me u, then plus or minus root u, hooray. How does that work though? Yeah, so an anonymous person in chat has immediately said, when you square root, the answer can be positive or negative. My intuition there is that, well, the quadratic for u has got two solutions, maybe, and then when I square root, I can do plus or minus, so I'll end up with 4, which is not what I want. I want exactly two solutions. Feels a bit like, generically, I guess I've got a power of 4 up here, 4 solutions, not unreasonable. Plan in chat is for b squared minus 4ac to be exactly 0, so that there's one solution to the quadratic, so 2 solutions to the quartic. I like that plan. Let's follow through. So your plan is to set, I think, just reading off here, I think your plan is to set k as 1/4. No, I'll stick with this colour, I think. K as 1/4. That gives one solution, which I think, if you did the extension I just mentioned out loud, which I think gives you u as 1/2, and then x is plus or minus square root 1/2. It's a repeated solution for u, but then the plus or minus from the square rooting gives you these two solutions. Cool. Suggestions in chat for question. People in chat also talking about question 2. Herb says, oh right, okay. Jessamine's got a different idea. Brilliant, okay. Jessamine's got a different idea, which I think is brilliant. You could have one positive root and one negative root. That's clever, because then u has got two solutions for the value of u is, but I'm not allowed to take the square root of the negative one. Only the positive one will give me real solutions for x. So separate question, when does that have exactly one positive solution? That's not obvious, I think. Yeah, Herb has told me about putting one solution in, and Ackles just told me about getting one solution negative, one solution positive. When does that happen? You could do some algebra for this. I prefer to think about this geometrically, I think. Let's go back to translating this thing up and down. Oh, that's not translation. There we go. So if I do something like this, here's an example where there's one positive solution and one negative solution. This quadratic is, I know it's labelled x, but we're now thinking of that being u. Here's an example where it's got two solutions and they're both positive. So that would lead to 4 solutions for x. So what's the difference? When has it got one positive, one negative? When has it got 2 positive solutions? Feels like it can't have 2 negative solutions after I translate it. Right, so in chat, a couple of people told me that k could be negative, and I think that's precisely right. In which case, if k is negative, u has one positive solution. So I'm writing really small, but I'm also talking. And then x is plus or minus square root of that. Running out of space on my split screen. Maybe it wasn't as clever as I thought it was. Chat question about A-levels, which I'll do now. The standard for this live stream, the stuff we're talking about, is in A-level. I think A-level is standardized between different exam boards. So the kind of content we're talking about. I'd hope that wherever you're learning maths in the world, at some point before school leaving, you get to do stuff like this. If that's not happened yet, then hey, here's a kind of introduction. I hope you learn about it at some point. If it's already happened, then hey. This is a bit weird. Our final answer is kind of 2 different cases. I think we're done though. Either u has got like 2 positive solutions, in which case rubbish, or exactly 1 positive solution, which could happen with a repeated root, or it could happen because one of them's positive and one of them's negative. If u's got no solutions, then x definitely doesn't have any solutions. So those are our cases. I know it's weird. There's an infinite interval, not including k equals 0, and there's a positive value. What's going on? And there's a way to think about this in terms of a graph, which I'd like to show you. He says, desperately trying to think about graphs. It's a picture of a polynomial again, and looks like this. So let's try and sketch this polynomial. Before we had a sketch of x squared minus x, let's try and sketch this one, x to the 4 minus x squared. I'm going to zoom in and try and sketch this. So things to think about when you're sketching a polynomial. What happens for large x, which is something to do with the highest power of x you can see, because that one wins when x is a big number. This one's x to the 4, so that means that when x is very large, this is going to be very, very positive. You can't see down there, that's because I've zoomed in too far. Okay, so when x is positive, this is going to be really, really huge. When x is small, this is going to be, I'm ignoring the k for now, I'm just trying to sketch this. This is going to be negative, I think. It's going to be like minus x squared. Okay, something like this, I think. I've got this idea that fourth power means you can have as many as 3 turning points because of differentiation stuff. I think it's got some solutions because I can see that if x is 1, then that crosses the origin. I can see it goes through 0, 0, so I'm pretty happy with my picture. Got about 3 turning points, kind of negative in between. So, different values of k then, where you get exactly 2 real solutions, are, well, you could add on any negative number. If you do that, then your graph will fall away down here and you'll have 2 solutions left over. If you translate it down, or if you translate it up exactly 1/4, I haven't drawn that well at all, have I? It's symmetric. So these 2 turning points will just hit the x-axis at the same time. That's kind of what's going on. There's kind of this general case where there's 2 solutions up here, and there's one special case where you just hit the bottom of these turning points. Why would we not use the discriminant of u squared minus u plus k? Oh, we did. Yeah, we did. Did it kind of out loud and not very well. Over here. So the discriminant was relevant for getting this value k equals 1/4 when there was to find one solution of u. But then there's this real subtlety in this thing Jessamy mentioned where we wanted exactly one positive solution. The discriminant doesn't do that. The discriminant tells us how many real solutions we've got, but they might be positive or they might be negative. Because of the square root, we're kind of interested in the positive roots. So this second bit of the argument to look at k being negative, that came from ideas about how many positive roots you've got, which sounds very similar to the thing the discriminant does, but is actually a different question. Then I went on a tangent about graphs. That's just what the live stream's like. Cool. We had a request for question 2, I think. What are we doing after question 2? Good. See, the nice thing about doing this live is that someone says, I don't get it, and then I say something, and then they say, they got it. It's just like teaching. Because it's supposed to be. Anyway, I love this show. I've kind of missed it. Yeah, if only you could bring your graphing calculator to the mathematician test. It's a non-calculated test. I should have probably said that by now. How are we doing? We're doing all right, I think. I'm going to solve that quadratic for 2, because it's a nice quadratic. I'll do that one. Then I've got a request for question 16 after that. Okay, shall I scroll? I'm going to write down the quadratic that we're solving, and I'm also going to scroll in case you want to read ahead. If you're on one device and you can't get the PDF or the web page at the same time as looking at the stream, then here are some more questions for you to look at. Request for 16. I respect that, because 16 is great. There's some factorization stuff in the middle. What am I going to put on the screen? I'm going to put 16 on the screen, and I'm going to do question 2. I know that sounds a bit weird, but we're going to give it a go like that. It's super weird. That is just abuse of the technology, right? Quadratic equation, let's go. So this is worth it because have I written that down right? I think I have. That's an equal sign. I haven't written that down right at all. This is worth it because this number's really good. It says when you we're looking for a number which when you square it you get 1 more. So first check, is 1 squared equal to 1 plus 1? No, because 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. Is 2 squared equal to... No, that's 4, which is not 2 plus 1. Okay, so it's not 1 or 2. It's somewhere in between. We can work out what it is by moving everything onto the left and then getting out our trusty quadratic formula. Discriminant inside here is b squared 1 minus 4ac, which is 5, all over 2. I want a positive solution, and root 5 is pretty big, so my positive solution is 1 plus root 5 all over 2. That's got a name, that's called the golden ratio. It's a really nice number, partly because when you square it, you get one more. It's about 1.6. And when you square it, you get about 2.6. It's just nice, sort of in between. Not sure what question 13 is asking for. Can I clarify it? Yeah, okay, I'll do that, and then we'll come back down to 16. 13 is looking for all of the zeros. That's all of the values of x for which that polynomial is 0. That's not great notation, but it is fairly standard, sorry. The values of x are referred to as the zeros because they give 0 as the result from the polynomial. Don't love it. I prefer roots, I think. But we've got both in the questions to kind of expose you to both. So can you find me any values of x which solve p of x equals 0? Which do you prefer, chap? Zeros or roots? I can go back and change all of them. Let's do 16. 16 is about hidden quadratics. There's a kind of joke answer to question 16. Should we do the joke answer? Let's do the kind of spirit of the question answer first. So the spirit of the question is that we write out for a quadratic like that, we try and make it look like a quadratic by choosing some u's. So for example, I'll give you the first one. That's equal to this if u is equal to x cubed. I can spot that polynomial up there, 2x to the 6 plus x cubed plus 1, is not a quadratic, but it kind of only involves x cubed. There's an x cubed, and there's an x to the 6. This is pretty good if I'm trying to solve that, because I could, if I wanted to solve y equals 0 or something, so e.g., not part of the question, but e.g. y equals 0 at 2u squared plus u plus 1 equals 0, do the quadratic formula, and then take the 1/3 root to get x out of that. That's the way we could solve that equation up there for y equals 0. It's just sort of a nice idea that if you can spot this kind of thing that's a disguised quadratic or something. Yeah, zeros of the Riemann-Zeta function is a phrase in popular science and in maths outreach, I guess. People prefer roots. I got 2 votes for roots, 1 vote for zeros. Okay. Maybe you can tell me in chat what you would do for the other ones. The last one is horrible. While you're typing or thinking about which one of these is the hardest, I'll give you the joke answer. The joke answer is just set u squared equals the right hand side stuff. Whatever's on the right hand side, just set call that u squared. So for example, just set u equal to the square root of x to the 6 plus x cubed plus 1. That's a function of x, and it has the effect that that polynomial up there becomes y equals u squared, which is just undeniably a quadratic equation in U. This is a bit of a joke answer because you can do it for all of them, and it's also not helpful. It's not helpful because I can't solve that bit. So if I'm trying to solve when is that polynomial at the top equal to 0, and I make this substitution, then it says, well, it's where u squared equals 0. Solve that quadratic. That's where u equals 0. Well, where's u equal to 0? Oh dear. It's not helpful. There's a second suggestion. 3 different people, Augustine, Anonymous, and Alex, 3 people whose names start with A, have picked square root x for the second one on the screen. I like that, because x is equal to the square root of x squared. And then I guess this is root 2 times root x, and you've called root x u. So good choice. You could choose to put some 2's in there, or indeed put everything in there. Oh yeah, Jessamine's gone for putting in the 2's in as well. If you put the 2 inside your definition of u, then it's going to turn up in other places as well. I can't quite tell how that's going to work. I'm going to try it out myself just to see. So if u is equal to root 2x like this, then I can see that second term there, that root 2x, brilliant, that's going to be u. What's this thing? So it is x on the screen at the top there. That's sort of u squared, but not quite, because u squared is 2x, so I need to divide by 2. Okay, it's not that bad at all. Brilliant, okay. And then Alex Knackle and BR in chat going for a suggestion for this one, underneath with the 3's and 6's in, to write that as 3u plus 6u squared, with u equals e to the minus 3x. Nobody in chat has gone for including the factor of 3. It's a little bit messy because you have to divide again. Maybe it's not a good idea to put the 3's in. These two, by the way, these are not joke answers. These are very clever answers. I guess it could be a clever joke. Anyway, these are clever answers that are not jokes. I like them because they also help you solve the equation. That's not part of the question on the board, right? But they help you solve the equation because these things are easy to invert. U equals root 2x, it's pretty nice, pretty clear relationship that I can undo. U equals e to the minus 3x, I can undo that if I know about logarithms. U equals square root of mess, I'm stuck. 6 log cos 30, that's a number, right? Maybe you mean log of a variable? What I do is expect some x's and u's maybe. I like the idea though of throwing in some logarithms. Nothing to stop you, right? Maybe you're telling me x is equal to some log u's. Anyway, okay. That last one is quite a bit harder than the others. We've got one person in the chat who's got something. They've chosen some fraction for u. The place this comes from is a sort of totally different bit of maths. Called partial fractions. It's not really important whether you've seen partial fractions or not. If you have seen partial fractions, then hey, here's a revision example. If you haven't seen partial fractions, then this is a kind of foreshadowing. Like how we have those younger people in year 11 or even year 10 or younger watching as well, who are learning A-level maths perhaps. Hey, let's learn partial fractions. Works like this. The thing is, I can't quite simplify this. Oh gosh, it's off screen. There we go. Can't quite simplify this as it is because there's no shared factor between them. I can two-step it first. Yes, anonymous person's just said two-step it. So first, a good idea is to write u is 1 minus x. Which doesn't turn this into a quadratic yet, but it does make it a little bit nicer, because up here, this 1 plus x, well, that's something like, I want this just in terms of u's on the right hand side, so it's tempting to say that that's u plus 2x, but I'm trying to get rid of the x's, so I guess I would say that that's 2 minus u or something. Is it 2 minus u? Yeah, it's 2 minus u. Cool, a little bit of linear algebra there, a little bit of rearranging algebra stuff. Here's the beautiful thing. If you do that, then this splits apart into two terms, right? It's the numerator on the top, I can split the fraction apart. And then it starts to look like a quadratic. Well, not quite a quadratic, right? Because these things are not u squared, it's 1 over u squared. But maybe you can see that we could then take v as 1 over u. And this would be 2v squared minus v. Which is not too bad at all. Can 2 zeros be 1 root and 1 other root? Oh yes, so question about polynomials, I think. Which question is that? I recognise that question. Oh yeah, it's question 15. Which there was a request for. Oh, I'm losing track a little bit. there it is. Can a polynomial of degree 3 have exactly 2 roots? Exactly 2 zeros? Why not? Zeros or roots, interchangeable words for me. The answer is yes, it can. If you think it can, give me an example. If you think it can't, then I guess try and prove it can't. Maybe I'm wrong. I've got lost confidence suddenly in the middle of saying that. A polynomial of degree 3 is sometimes called a cubic equation, and we don't have, well, I mean, we don't know at this point a version of the discriminant for cubic equations. If we had a discriminant thing, we would say, aha, so get out my discriminant for cubic equations, and it says, aha, the thing is bigger than 17. That magically means that it's got 3 solutions. We don't have that technology for cubics on the syllabus, let's say. You might like to try and invent that. You might like to try and invent that. People in chat talking about complex numbers, so it's maybe a bit of a spoiler for me to say that MAT doesn't use complex numbers. No complex numbers on the syllabus. You're allowed to bring them into questions if you want to, but it very rarely helps. It doesn't specify real. I think it's still true. I guess it depends whether you're counting with multiplicity or not. This question could be clearer, couldn't it? Maybe this is why I'm getting questions in chat. If it's counting, okay, there's this phrase counting with multiplicity, which is not in the question. If it said counting with multiplicity, that means counting a repeated root more than once. It's a little bit of a tricky concept. Counting with multiplicity doesn't just mean that repeated roots count twice. A repeated root could count 3 times. So if you're counting with multiplicity, and Miles, if you're using complex numbers, then the answer is no, they've always got 3 zeros. Some of them might be complex, some of them might be repeated, but if you count with multiplicity, then there's 3. I think the spirit of the question here is that they're looking for if we're looking for real zeros and we're not counting with multiplicity, then you might have exactly 2. Okay, I think the question is quite ambiguous. It's more ambiguous than I'd realised. This is why I love the MAT Livestream, right? You write a question that you think is kind of clever because it sounds like no, but the answer is yes, and then chat comes along and says, yeah, if you're counting with multiplicity. Somebody in chat has quoted FTA, which stands for the Fundamental Theorem of Arithmetic, which is a very advanced concept that does use complex numbers. Somebody says they go to a school where they call them fake numbers. How did I get 2 minus u in the numerator? Yeah, and this quadratic business. People are unhappy a bit with this. Miles has done the thing where Miles has done some rearranging for me, but I'm going to do it on the screen as well. So I suppose what I really did is I rearranged this to be x is 1 minus u, and then plug that in up here. So I'm trying to replace the x's in preference of u's, so it helps have an x equals kind of statement. I don't know why I didn't write that down. I should probably have written this down. It was in my head. Yeah, okay, and then just plug it in. So not too mysterious. Rearrange this, x on the left, u on the right. The live stream is 2 hours. We're going until 7. It's getting longer. As the days get longer, the live stream gets longer too. We've had about an hour. We're going to move on to the MAT questions, I think at 6 o'clock. So last requests for other bits from the revision questions. Let's put the second half back on the screen again. We haven't looked at those last 2 down there. I think if there's no preference, I'll talk about 17. But if you want an earlier question, then we can look at those as well. If you just want to check a numerical value, there are solutions on the MAT Live stream page, of course. Good. Reese says 17, and I've forgotten what the question is. I'm really sorry, Reese. You put 17 question mark and memory of a goldfish. I don't know what that is. I mean, I know kind of what that is. Don't forget to drink water. 17's a good one. Jamie's agreeing. What's going on? Why is everyone talking about 17? Oh, question 17. Question 17. Let's talk about question 17. Because I just talked about question 17. I get it. Thanks, Reese. Right. There's a vote for question 17 in chat. Can I really do 2 hours of this? What will happen? And there's a request for question 6 as well. Okay, let's talk about question 17. I kind of like to know what your choices for question 17 are, and then I'll pop back up to question 6 as well. Yeah, 6 is quite nice too. Okay. So we're told a polynomial's got some roots at 2, -3 and 1. What could the polynomial be? I'd like at least 2 possible polynomials with different degrees. Okay, so I know that it's got a root at 2, so the factor theorem says that it's got factors. I guess I'm writing this out as a full sentence. Has factors of x minus 2, x plus 3, and x minus 1. So Shamina has got a correct possibility. It could be x minus 2, x plus 3, x minus 1. George says just expand it. Let's not expand it. Let's leave it like that. That's a polynomial. Let's just leave it in that form. I like that you put just expand question mark. Anonymous has put, and Gregory have got, Anonymous has got a pretty snazzy one that we're not told about whether there are other factors. So Anonymous in chat says that it could be this. If there's another factor. In fact, they've put a large number out the front here to make the point that we also don't know if there's a kind of big number out the front. It's called a leading coefficient, I think. It's that number A that I was talking about before for happy and sad polynomials. You could add a whole bunch of x's. So yeah, this one, if we're playing this game as well, then you could put other stuff out here so that you could set the degree to be something else. We're also, some people might not be happy about this because maybe you think that the language in the question is telling us all of the roots. I guess it doesn't quite say that. So I'm happy with this, that there could be another root at 0. Even if you're not happy with that, I think the question still works because even if you insist that it's only got roots at 2, -3 and 1, then it's still possible to play with the degree because we can put powers on here as well. Putting powers on here keeps the roots in the same places, but now they're repeated roots. Question definitely doesn't say whether they're repeated roots or not. So this has got roots in all the right places. Option to add in some roots in other places. Anonymous and chat's put in 0. Option to make those repeated roots, and option to throw in a number out the front. All of this together says that q of x has the form. Really called q of x in the question. That was a really poor choice. X minus 2, x plus 3, x minus 1 at times r of x, or for some r. That's like the factor theorem, right? It says that there's some multiplying polynomial multiplying these factors. And that could be anything. It doesn't have to be 1. That's maybe the first thing that you write down. The most obvious thing is that, maybe the remainder, not the remainder, maybe the leftover stuff, multiplying it is just 1, in which case it's this thing. But it doesn't have to be. The factor theorem doesn't say, here's your factor, there's nothing else going on. It's that whole other polynomial. Alex wants to use roots of polynomials for number 18. Yes, so for number 18, it's got a double root at x equals 1, that's a repeated root, so that it's a root twice. I can think of a couple of ways to do question 18. One of them is to, well, first let's check the value at x equals 1. Plugging in 1 should give us 0. That tells us something about a and b. And for the other fact, I might try and do some polynomial division, or I might look at the gradient. If you know about gradient of a function, the gradient at a repeated root is 0. So I might look at the gradient at x equals 1 as well. Those are kind of two different methods, one where you start doing the polynomial division, and one where you just differentiate it and say that the derivative is 0. Could you do something like, oh my goodness, suggestion in the chat, let me just check if this works. Sorry, this is for one person in chat who suggested this. That's got a root at 2, that's got a root at -3, that's got a root at 1, and it's got some crazy big degree like 9 or something. Yeah, that works. It's got roots in all the right places. And, oh, it's got roots. Has it got any other roots? I'm not sure it does. I think those are all the roots. Yeah, cool, I like that. This is where the polynomial r of x doesn't need to have any other real roots. It could be a simpler example. You could put r of x as 1 plus x squared. There's something over there, which for your r of x. Again, I wouldn't bother multiplying it out for this question, but just to write it down, the obvious factors multiply by 1 plus x squared. Ooh. It's got roots in all the right places. This thing doesn't have any more roots, but it still modifies the degree, modifies the polynomial. It doesn't have any real roots. How could it possibly be the case that x squared plus 1 would be 0? That'd be terrible. Yeah, double root is a sort of repeated root. I'm being really vague about that, aren't I? I should be less vague. Should I be less vague? Less vague. We've just gone past 6 o'clock, but I'm being vague. So this thing has got a repeated root at x equals 1, which is a double root. It's a double root, I guess, because of this power of 2. It's a good way of thinking about it. Double root because of the power of 2. It's a little bit like you had two different roots that just happen to be in the same place, because quadratics have usually got two roots. This one's just special that both the roots for that quadratic are in the same place. Feels like it counts as 2. This one, this polynomial, has got a repeated root with sort of, it's called multiplicity. It's not really on the math syllabus. I wouldn't expect you to know this word, but I'm teaching you this word. Multiplicity 3. Well, I guess I'm talking about the power up here. Multiplicity 3. That matters if you're trying to count the roots and you want to count them with multiplicity. That's something that people do. It's a bit more advanced than math or A level, but counting roots with multiplicity is something we do. Yeah, roots of polynomials is further math, so it's kind of not really relevant for actual math, but we were nearby, so there we go. We were in the area, so we popped by. Okay, quick break to remain human. Remember to look away from a screen if you've been looking at a screen for the last hour. Remember to drink water and I don't know, what else do humans do? Eat food, but there's probably not time for that, right? The signs of life. Grow. Remember to grow as a person during this live stream. Okay, I've got a couple of math questions. It's an odd numbered year, so we've rebuilt the question sheets. Last year, at this point, I would have taken us slowly through some multiple choice questions. Matt has got this big section at the front with multiple choice questions. But in response to some feedback, I think we should just get on with looking at a long question. I'm excited. I think there's a different way to do it. We're not speedrunning Mrs. Gren. This is not a Mrs. Gren speedrun. For obvious reasons. Right, good. Okay. Here's the polynomial, and it's the one in the thumbnail as well. So if I don't talk about it, then this is clickbait. So very important that we talk about this quadratic today. N is a positive integer. Integer means whole number. Past papers have kind of switched between whether we say integer or whole number. Maybe you know both words, so it's fine. X is a real number. Brilliant. We've set up the rules at the top there so that we're not talking about complex numbers. That's a shame. the parts of this question, so just skimming through what this question looks like, the parts of this question get us to first explore the function and then get into the kind of point of the question, which is what happens when you apply the function multiple times. So in part 2 down here, write down f1, but then calculate f1 of f1 of x. We'll talk about that notation in a minute. We're going to build up to talking about applying it k times, and then we're going to talk a little bit about applying f2 k times. So that's the math question. I think that's all of it as well. I tried to pick out one that looked quite approachable for our very first one on the live stream, 1 hour in. One vote in chat to stop talking about biology. I think I can go with never talking about biology again on this stream. Let's find out. Challenge accepted. Okay, my plan is that, I guess, time-wise, spend the next 20-30 minutes just talking about this question. In the actual test, I reckon that you would spend about 22.5 minutes, something like that, maybe a little bit more, doing a long question. We're not really trying to do stuff at speed, especially because I'm getting distracted talking about things in chat, and also because I'm explaining stuff as we go. So don't want chat to be cross if we take more than 22.5 minutes. Okay, what's the mark distribution? So the marks are, there's different numbers of marks for each part of the question. In past papers, it's not shown, but it feels like a stupid place to do announcements. For the first time this year, we're printing on the question paper how many marks each part is worth. So 2023, we're going to stop making it a secret and start telling you how many parts each question is worth. So when you're looking at past questions and in the MAT Livestream episodes, I'm not telling you, kind of because in the MAT Livestream I don't really care about marks. I care about method and doing stuff along the way and learning. When it comes to the actual MAT test, we're going to tell you how many marks each part is worth. I haven't done that before. Hi, Oscar. Miles says this function is maybe a swap between being happy and sad. I guess Miles has spotted that -2 to the power of n. Let's have a quick think about -2 to the power of n. That's -2, then it's 4, then it's -8, and then it kind of switches around a lot. So yeah, people are skim reading through. And Jay wants to know about the format because I just said printed on the question. We have a plan for how people are doing the question. I'm not sure. It's being announced in a couple of weeks. In time for the open day at the end of the month, I've been told. So that when thousands of people come to the open day, we're allowed to tell people. You will find out on this live stream or on the MAT website. Don't panic. Nobody's panicking, right? Is Oxford doing an admissions test? Ah, right, okay. Hi, good news. Oxford does an admissions test. It's called the Maths Admissions Test. This is a question from it, from 2007. People sit it roughly the time of the UCAS deadline. So people register just before they put their application in. It's going to happen later this year. We'll walk you through it, don't worry. And people sit the test just around about the time of the UCAS application. There's this test date, that's the 19th of October, 2023 this year. And then Oxford used that. Good. Is it worth coming to another open day if you've been to a previous one? If you've been to the departmental one, then you've already seen pretty much everything we want to tell you about maths at Oxford. If you've come to a university one before, then you've also seen some colleges. You've also travelled around. The summer ones are a little bit different because all the colleges are open at the same time. It's really busy, and it's also, if we're lucky, really sunny. If you live nearby and you want to see Oxford in the sunshine, I can think of worse things to do, but maybe you've got school because it's during the week. What am I talking about? F1 is a linear equation as an observation. There's a guess here about whether it should be even or odd for maximum or minimum. Even or odd, evenness and oddness. I like that because this minus sign inside that -2 to the power of n, that really feels like an even odd kind of thing. It's kind of a trick I've used in Desmos before. Let me just show you a quick thing, sorry. So sometimes you want a little machine that switches between two states depending on whether it's even or odd. And Desmos doesn't have a function for even or odd. So what you end up building sometimes is something like this, This is 1 if n is even, and it's -1 if n is odd. So sometimes that's exactly what you want, but sometimes what you wanted was something that's 1 or 0. But you can do that because if you add 1 and divide by 2, so if you think about this, that's lovely because if n is even, then this thing is 1 and it adds up, and 1 plus 1 is 2. Welcome to the Oxford MAT Livestream, divided 2 is 1. So this is 1 if n is even, and it's 0 if n is odd. So we've built an evenness detector. It can tell if your number n is even or not, and it returns 1 or 0, which is sometimes that's just what you want. You want a little thing that just keeps track of whether the numbers are even or odd. People in chat are discussing whether it should be even or odd, but also the open days. I've met several people. Several people have come up to me at open days or other events and say, "Hey, I've seen your live streams, which are then very weird." It was not weird, but it's a reminder that there are real people watching. From my point of view, I'm alone in my office, surrounded by tech. I'm trying to tell you about even odd detectors. It's very weird. Then people turn up at actual events. If you see me at an open day, say hi. Right, if you see me on a degree, then say hi. If I'm teaching you on a degree, then say hi. Right, f3 of x. It's a nice opener to the question because it's checking whether we can plug in the value of 3 and then do some evaluation. So notice that I'm plugging in n equals 3 and I am not plugging in x equals 3. So there is a big difference. This is -8, so this is -6 x squared. This looks like the sort of function that has a maximum, because that -6x squared means that for very large x squared wins, and -6x squared is negative. So this is a quadratic that goes down for large values of x and large negative values of x as well. That makes me feel like it's a mountaintop, got a maximum. Are the open days worth it if you've been on an outreach event? Look, the open days are kind of a bit of fun. You come and you see Oxford, it's lovely, you visit some colleges. You don't need to come to an open day to apply to Oxford. When I was applying to universities, I went to a couple of open days. For one of them, I bumped into someone I'd seen on a previous thing, and we just talked about maths and we forgot to go to any open day sessions. And on the other one, I went to about one maths session and I had lunch, and I can't even remember if that didn't affect my application. Would I recommend applying to a new college? I'm talking about polynomials at the moment, and I'm talking about new college. Bits of Harry Potter were also filmed at Christ Church, which is another college in Oxford. These are not amazing reasons. It's not very much Harry Potter, and also Harry Potter was fictional. Right, sorry, that sounded really patronising, I'm so sorry. I love Harry Potter, what am I doing? Okay, find the maximum value. Right, okay, so I've been saying, oh, it looks like it has a maximum and explaining why it has a maximum, and all that time up there on the screen it says find the maximum value. Brilliant stuff. Two methods here. We could do some differentiation. So we should do some differentiation to say, well, I want -12x plus 6 to be equal to 0. That happens when x is equal to 1/2, where the value is, and then, oh my goodness, I'm going to have to work out fractions. Nobody told me there would be fractions. The value is 1/2, 1/4, 6/4 is -3/2, plus 3 plus 9, so 12, take away 1.5 is 10.5. Ugh. I'm putting that over there. Alternatively, we could do some sort of complete the square thing, which is probably more on theme for today's episode. Completing the square is a little bit hard with the number at the front. Sometimes I like to divide everything by that number, just to make it a bit more familiar. So like this, right? X squared minus, not 6. Divide by -6. Divide by -6. I can do it. Divide by -6. I did it. Yeah. And then complete the square on the thing inside. Sometimes if I'm feeling brave, I might just go for it and write out the -6 out here, and then just try my hardest to track what do I write down here after I square this term. is going to get 2 times whatever I write, times 1 minus sign, oh my goodness, that's going to cancel the 6. I want 2 times the thing to be 1, so 1/2. Then the constant on the end there is going to be not 9, because this 1/2 is going to get squared. And that'd be 1/4 times minus 6, minus 3 over 2, so I need to add on another 3. Oh my goodness. It feels like a lot of work to try and do that in my head, right? So don't be afraid to 2-step it. To do it in 1 step, pull out the factor at the front, and then 2-step. Complete the square. Do you do a test and interview? There's tests and then interviews. In general, admissions process facts, we can get there. For this question, is it fine to just write the expression or degree without explanation? Yeah, I think down the end, for the last part of the question, it does ask for the degree, and it doesn't say to explain. To be honest, I think I probably would explain. I'd probably put something, just in case. If you're wrong and you write nothing else, then you're definitely not getting the mark, right? You write something wrong and there's nothing else. If you write something wrong but you put a reason that's almost right, and it's clear that you had the right idea, you just added 1 by mistake or something, then you might get a mark. You might get some mark for being close. So I kind of always encourage people to write down some sort of reasoning, or write down just something, show you're working, even if the question doesn't say, because then even if you're wrong, you might get some credit for clearly being close. If you just write down 3 to the k and that's not correct, then it's like all or nothing. Is it easier to leave the 9 outside when you're completing the square? Maybe. Oh, you just leave the 9 outside. Yeah, you're right. I should have left the 9 alone. Yeah, you're right. I've moved it inside the bracket and then I'm going to complete the square. That's stupid, isn't it? Should leave that alone. Yeah, point taken. 1-step it. Just leave the 9 outside. Good. What's the process for finding minimum and maximum by completing the square? Well, it works like this. Once you've completed the square, lovely format, this bit, pink box, this bit is less than or equal to 0, because squares are always positive or 0, and this one's got a minus sign out the front, and a 6, but it's got a minus sign, so this term inside the pink box is always negative. That means that the maximum value happens when the box thing is 0, which happens when x is equal to 1/2, and the value is 10.5, this thing over here, the leftover bit. It's sort of, because x only appears in one place, it's much easier to talk about how the value changes. Can you just differentiate and sub in the value? Yeah, that's what I'm doing down here. Let's differentiate it, and then sub it in. The value is 10.5. If you know calculus, then this sort of maximum minimum stuff is not too hard at all, right? Can we do a brief introduction to the last part? Ray's on the last part already. I think, yeah. Jay's told me a brilliant thing about leaving the 9 outside. Sorry, catching up with chat. Brief induction. Yeah, okay, so doing mathematical induction sounds like quite a bit of work, but maybe when we get there, we'll think about doing a bit of induction. Let's scroll down. Good, okay. Square brackets are always for comments or notes. This one says we're not being asked to calculate the value of the maximum. Oh no, I haven't done this part of the question. I've scrolled past the question. It says, for what values of n does this thing, which is just going to disappear off the top of the screen, there it is, have a maximum value as x varies? Okay. Oops. I've lost everything. Help. Things went bad for a moment, but we're back. I've now got the question on the screen. So up here, what do we have? It's something people were saying about odd and even things, I think. So it's quite tempting to say something like, is n even or odd? And that's kind of the relevant distinction. Because we're thinking about whether 2 plus minus 2 to the power of n is positive or negative. There's a sort of special case that if you don't spot the special case, it's coming up in a minute, so there's a chance to spot it in a second. But this thing is actually equal to 0 if, and maybe you can spot when it's equal to 0. So in chat, BR says n has to be greater than 0 and odd. Yeah, we've told in the question it's positive, so I agree with that restriction that it should be a positive integer. Positive and odd is not quite enough. There's a special case. Yeah. Jay says, if it's tricky, draw a picky, which seems pretty good to me. If the coefficient out the front there is positive, it's going to be like this. If it's negative, like this. If it's 0, then flat line. Not flat line, line like that. Jamie wants to find the second derivative. Yeah, here's what happens if you do the second derivative. You get 2 times the number out the front. And maybe that's a good reason why this is the term that matters. That ax squared term contains all the information about whether this thing has a maximum or a minimum. Yeah, people in chat are getting there now. If n equals 1, then special case, this thing's 0, and our function's in fact a linear function in that case. It's the linear function 4x plus 1. That's coming up in part 2, but spoilers, in that part that's coming up now, if n equals 1, 4x plus 1. I suppose I don't need. I'll leave it. Which doesn't have a maximum because you can make x really big. And I guess maybe that's obvious, you can make x large. So we need n greater than 1 and odd. Something to imagine perhaps is that this minus 2 to the n is going to become really large in magnitudes because exponentials, right? 2 to the n, huge numbers. But it takes a little while to get going. And for the first few values of n, we should be suspicious that this 2 plus could matter. So different version of the question for you to think about. If it was actually 20 plus minus 2 to the n, then it's a little bit different because, again, minus 2 to the n, eventually that's going to win. That's going to be huge, much bigger than 20. Forget 20. This thing is going to be controlling whether it's positive or negative. But for small values of n, that 20 really matters. The minus 2 to the 1, it's only minus 2, which then 18, not a negative number at all. 18, not negative. It's a little bit. There's a little bit of a lesson here about how different things could be competing. So sometimes one of them is more important, and sometimes the other is. Yeah, so there is some shorthand notation. This question has decided not to use it, so I'm going to try and avoid it as well. Gregory says 1 is the special case. Anonymous says n should be greater than 1 and odd. Okay. Right, part 2. Also going to zoom back in. Okay. How are we doing? We're doing okay. We're doing all right for time? Yeah, we're doing fine for time. 22 minutes. This is the point where chat gets upset. We haven't done the question in 22 minutes. f1 of x. And then we're asked for f1 of f1 of x. Which means that on the outside here, we've got an f1 of x. So I want to write down 4 plus 1. I know how to plug in x to f1 of x. But in here, not so clear, right? So in here, I want to plug in f1 of x instead. Maybe I'll two-step it and I'll write down f1 of x for now. That's the outside f1 of x. And then the inside one there, this thing is also 4 times something plus 1, but now it really is x. Okay, so we've got 4x plus 1 inside this bracket, and then it's, again, multiply by 4 and add 1, which is a linear function, right? It's still linear. I've only got an x here. What is that, 16x plus 5? Gosh, okay. Yeah. Jamie can see a geometric sequence coming, so that's foreshadowing, I think, the way that these are. There's some powers of 4 around and some adding. Feels like things are getting a bit geometric. Okay, we're asked for f1 of f1 of f1 of x. Oh gosh, sorry. Here, perhaps the best thing is to realise that all this junk on the inside of the outermost brackets is the thing that we just had. So this is f1 of 16x plus 5, which means that it's 4 times 16x plus 5 plus another 1, which I think is 64x plus 21. So there's a pattern here. There's a pattern here which is to do with how there are powers of 4 around. We're asked to extend this to apply f1 k times, which some people do write as f1 k of x, but that's just too much stuff going on, right? fn k x, it's too many letters for the alphabet. I mean, people do it. We're not going to do it today. The pattern here involves the fact that every time we multiply all the stuff we already have by 4 and then add 1. I think the easiest way to identify what's going on is to actually not simplify the constants. So here I've simplified them down to 5 and 21. I don't really recognise those numbers. But if I leave the 5 as a 4 plus 1, because that's where it came from, remembering where you come from, and this 21 as a 4 times, and then if I'm not writing 5, I'm going to write it as 4 squared plus 4 plus 1. That's where it came from, because it's 4 times the previous thing, 4 squared plus 4, and then another 1 on the end. Now I think I stand more of a chance of spotting the pattern. There's some pattern here that goes 1, you can't see that one off the top of the screen, there we go. Some pattern here that goes 1, 4 plus 1, 4 squared plus 4 plus 1. And I can extend that, right? That's some sort of powers of 4 and add together however many of them there are, which is like there are k terms in the sequence. Hey, it's not so bad. So for today, I'd be happy to have that. Yeah, so Shamina says, is it 4 to the k x? I agree with that bit. Plus some stuff to do with 4 to the k minus 1 and then some more stuff. So today, I think I'll leave it as 4 to the kx. Well, then you've spotted that it's multiplied, the coefficient of x is multiplied by 4 each time. So my final answer up here, I'm now answering the last part of the question, I suppose. Obviously in the actual test, I would work down the page, but my page is about 4 times as wide as it is tall on the screen, so needs must, right? 4 to the k minus 1 plus 4 to the k minus 2 plus dot 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 plus 1. I'll try and keep some sense that I've spotted this pattern where you just add together powers of 4 going all the way down until you get to plus 4 plus 1 at the end. Yeah, which you could even write as 4 to the 1 plus 4. Yeah, I quite like that actually. If you finish your sum as dot 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 plus 4 to the 1 plus 4 to the 0, that's snazzy. I like that. Exploiting the fact that that 4 in there was a 4 to the 1, and these 1s that are around, that's 4 to the 0. I like that a lot. Some people in chat know how to sum that series. I don't know if it's everyone. In a few weeks' time, we're going to do an episode on geometric series. That might be a new phrase for you. A geometric series is kind of the sum of a sequence. Here, you can kind of see there's this sequence 1 and then 4 and then 4 squared, and we're being asked to add together the terms of that sequence. There's a really nice formula for this. Hiding behind it, there's some really nice maths, but this thing actually simplifies really nicely. The thing to spot is that 1, 5 and 21 aren't very familiar. If I triple them, I get 3, 15 and 63, which are a bit more familiar. They're just 1 less than the number I had at the front. So the answer is actually 4 to the k minus 1 all divided by 3 for that constant term. Where on earth did that come from? How do I think about multiplying by 3? Why would you ever multiply by 3 and then spot a pattern? There's this great theory about geometric series that answers all of that. Yeah, so 4 to the k minus 1 all divided by 3. No formula sheet for the mat. This is the sort of thing that you might try to memorise before going into the test. Once you've learnt it, right? This is quite fun. I think everyone at some point is going to be in the position where MAT Livestream is how they learnt a thing. Maybe it's already happened to you. Maybe you've already learnt a thing. I don't know. Maybe this is a huge waste of everyone's time. I don't know. No way to tell. I'm having fun. This is not a waste of my time. Right, okay. I'm going to speed up very slightly. What have we done? We've simplified it as much as possible. For today's purposes, I don't really mind if you've seen this geometric series fact or not. We've got this last bit of the question about F2. where for f2, we want to write down the function with 2's in. It's disappeared off the top of the screen for you, but that turns out to be 2 plus minus 2 squared x squared plus 2 plus 3x plus 2 squared, which is, a bit awful, isn't it? So that's 4 and 2 is 6x squared plus 5x plus 4. And then the idea is that every time I plug this function back into itself, I get, so here's the first one, I get the thing I had before gets squared plus more stuff. Less important stuff, no squaring. The squaring is big. Terrifyingly large powers coming out of this thing. And that includes, if I ignore these bits as well, that includes like this thing has been squared, so I end up with some sort of hideous coefficient out the front times x to the 4 plus stuff. And then when I pump it through f2 again, it gets squared again. So then after that, I see something even worse times x to the 8. And then I see something even worse like x to the 16. Every time you square this, the power doubles. So the degree is 2 to the k. And then I might write something like doubles every time. This is a good hedge because if I'm out by 1 in my power, then I still get probably some credit. Miles asked about memorization. Miles just asked a question about formula sheets. We don't expect you to memorize very much. Like the quadratic formula, you probably just pick it up by experience. And the geometric series thing is not that bad either. It's really not a test of rote memorization. It could be much worse. There could be a lot of rote memorization. I don't know if we've ever done a formula sheet, but I'm thinking about reasonable modifications, right? Some people have in the past got the test printed on a different colour paper or a different size or something. I don't know if we've ever done a formula sheet as a reasonable modification. I'm not really sure what we would put on it. Yep, Gregory's right in chat. 2 to the k. Would you get the mark for writing the first answer? What was my first answer? Just writing 2 to the k. Yeah, okay. Extension 1. Jay's found the extensions. Where did I put the extensions? Oh, under the hints, right? So there's some hints for this on the sheet, which are kind of mostly there for people not watching the stream, I suppose. Some extra bits which are just for fun. I even wrote it on the sheet just for fun. What happens if I wanted to think about what happens when you apply fn. This question just stops now after f2. I wanted to think about fn as well. I wanted to give that a chance to be applied k times. And then hard question, think about the leading coefficient. And then I've made a variant version with GNs, which is slightly sneaky. So if you want to play with something that's a little bit like this question we just did, but harder, I don't know why you'd want that really. I know I do. Messing around with maths is sort of unrelated to preparing for mathematician's tests, but hey, we just did some work. No for part 2. Cool, right, okay, I'm getting confused by chat lag again, but I'm just going to leave it. Right, short pause while I think about what the thing is doing. And we're going to do this one. This is also an example of a question that is lightly modified. Quickly reset that. Remain human. How are we doing, chat? Are we all right? We're losing people a little bit, I think. Was that too much detail, too fast, not useful enough? I want this to be good for the people who are here live, and of course people watching the replay at home or watching this at double speed. Although if you're watching at double speed, don't tell me that it was too fast, because you're in full control over that in a way that people in the real one-to-one. Jay says good speed, but it's quite tempting for me to just take the first reply and then not look at chat again, but do let me know. In particular, there's some people asking like follow-up questions, and because I have a bad memory and we move on a lot, I'm worried that I missed the follow-up questions. It's quite, I missed the follow-up question. I don't know what you're asking about, so I just move on to the next thing I was going to say anyway. Okay, I'm going to try and do the next one, even if anything, slightly faster. Cool. Jamie and Shamim are also keen. Okay. I was talking about formula sheets. Good. Right. Okay. Right. Woo. I don't know how I'm going to do this in. For context, it's quite a warm day, and I've got a lot of maths going on, and I'm running a lot of computer stuff. This question is super cool. I like it a lot. Here's the structure of the question. Why am I clapping? 2 hours is quite a while. For context, we've been doing, for the last couple of terms, live stream that's been about 1.5 hours, so just past the point where, I haven't done a 2-hour live stream in a while. I know that's not long by live stream standards, but here we go. It's 6:30 and time for a math question. Suppose that x satisfies this equation, x cubed equals 2x plus 1. Spoilers for this question, we are not going to solve for the value of x. There are, in fact, 3 solutions for the value of x. It's a cubic equation. Maybe you know the cubic formula. It's not on the math syllabus, and it's not in A level. But hey, for some reason, maybe you know the cubic formula. If you know the cubic formula, you could just solve that cubic. Let's not. Let's just not do that. The real trick for this question is going to be deducing new facts without actually solving for the value of x. For example, I hope you can see the relationship there between the thing we're given at the top, x cubed is 2x plus 1, the relationship between that and x to the 4 equals x plus 2x squared. I hope you can see how both sides of the equation have been modified. Also, someone slightly cheeky perhaps has switched some terms around, but I hope you can see that just comes from multiplying both sides by x. Whatever x is, even though you don't know the value of x, you can still multiply both sides by x, and that gives you this deduced fact from the previous one. Good. Okay. Given that cubic, I want to multiply both sides by x. So I like it when I'm reading a question, I'm already trying to think about how to do it. There's an x to the 5 factor there. My pattern spotting bit of my brain is going x cubed, x to the 4, x to the 5. I'm going up by 1 each time. I'm going to multiply by x again, and then make that work. Kind of 2 steps there. Have an idea, and then make it work. I think different bits of my brain. I promise not to talk about biology. I don't know about biology. I'm not a real I'm a maths doctor. Right, good. Okay. People in chat are having a go at x to the 5. There's a trick. There's a substitution trick in there as well. The first thing you write down for x to the 5 is probably, I'm going to multiply by x again. X squared plus 2x cubed. Oh no, that's not the thing in the question. I've got a tip for that, which I think I put in the hints, or maybe in the solution or something. Let's have a look. So the thing I get when I write down just by multiplying each side by x is this. That's not the thing in the question, because the thing in the question is 2 plus 4x plus x squared. Now, it's possible I've made a mistake, or it's possible I haven't thought of the next idea yet. Either way, I want to spot the difference on these two expressions. I haven't talked about this on the stream before. I put it in the either the hints or solutions or somewhere, but this kind of spot the difference technique for when something hasn't gone right, or maybe it's just not finished yet. It can be helpful to play, the x squared, I've got that, so I'm feeling happy about x squareds. I've got both of those, but then the bit that doesn't match is this 2x cubed and this 2 plus 4x. They don't match. Maybe I'm wrong, so I think back again, 2x squared, I multiplied it by x, I got 2x cubed, I'm just definitely right, I've definitely multiplied correctly, so maybe I need a new idea to turn this 2x cubed into 2 plus 4x. If I'm really tracking it down, I can maybe notice both of these things have got a factor of 2. Is it x cubed? Could that be equal to, hang on a minute, I had a fact on the screen. Right, and then you have the idea that you can have another step. And the next step is to say, but x cubed is equal to 2x plus 1. which is good because then the factor of 2 is there as well. Everything kind of clicks into place. Being able to detect your own mistakes is an important skill. Okay, there weren't any mistakes on the screen, maybe. But being able to compare what you've got with versus where you're trying to go can help reveal which direction to go in, what should change. I'm making a big deal out of this. Maybe it was obvious to you at home that we should substitute for the x cubed using the given fact. I guarantee that at some point you'll come up with against a question where you're not sure how to rearrange something or not sure how to make progress, and sometimes just comparing where you want it to go and what would it be good. It would be good if these terms were equal to each other. Can I think of a reason why they're equal to each other? Oh yeah, okay, now I'll write down my reason and go from there. It's a little bit of working backwards from the answer, which I don't always love as a technique, and it's a little bit of checking for mistakes, which I love as a technique. For example, I guess if I'd multiplied by x wrong, I've made too much of a big deal about this already. Sub in the original equation, says Charlie in chat. Yes, Charlie, sub in the original equation. Good, okay, so that gives us this thing in the question. Good. Part 2 says we've now brilliantly succeeded in our mission. We didn't know we had this mission, but we've succeeded in this mission to write x to the power of k as a quadratic in x. Okay, fine, good, I suppose we did. We had x to the 4 was some quadratic. Let's take a moment to look at the way that the numbers match up. I guess c is the coefficient of x squared, b is the coefficient of x, and then there isn't a constant in that quadratic on the left, so a4 is 0. Okay, and then the 5 one is about x to the 5, and the coefficients are 2, 4, 1, so a, b, and c subscript 5 are 2, 4, and 1. Okay, good. I think I've worked out that that's what we were doing. We were making quadratics. That's a quadratic. Good. What does it want us to do? It's to show that question. It says, show that a subscript k plus 1 is equal to ck. This is now just relating together the different things. So spoilers, if you want to just go and do this question, maybe your intuition is to just keep multiplying by x, right, and keep substituting. That works. That's great. Great intuition. I want to do a moment of explaining how you might have that idea. So if you've already had the idea of, I'm going to keep multiplying x, it was working before, I'm going to keep doing it. For these higher powers of x, I'm just going to keep going. I want to give you an idea about how you might have that idea. And again, I'm sorry if this is obvious to you, how you might start making progress with this question. But what I found is that that's the tricky bit for a lot of people. Maybe not on this particular question, but we can talk about it. How do you get started? What's the first thing you write down? How do you have the idea about what algebra to do? We can all do the algebra, I think, once you start multiplying by x and stuff, right? But how do you have the idea to do that? So here to show that question, the thing we're being asked to prove is on the screen. We're kind of looking for a reason why it's true, which means we need to get to grips with what it is. If we're unlucky, it's just some random mess of A's and B's and C's. Some obscure connection between the A's and B's and C's that I'm never going to guess. But maybe I can get to grips with it and work out what do these particular equations look like? What are they telling me about the A's, the B's, and the C's? That's actually more important, I think, than getting all the factors of 2 right. It's just having this observation that in each case, there's something on the left, and then 1 or 2 things on the right, and the subscripts aren't random. The subscripts are kind of the same in between all of them. Yeah. So the subscripts there are not random. The ones on the left are all k plus 1 in the subscript. Subscripts are the small writing underneath, right? That's keeping track of what the power of k is, I guess. And on the right, what the power of x? On the right, they've all got subscript k. And I've remembered that that subscript relates to what the power was. So the stuff on the left of these equations is something to do with x to the power of k plus 1, and the stuff on the right is something to do with x to the k. I'm not being precise yet, but just by looking at the subscript and remembering the definitions, I can see there's something going on with x to the k plus 1 and x to the k. Okay, so idea x to the k plus 1 versus x to the k. And I recommend writing that down, to be honest, because then you can look at it as if it's an easier question. So easier question, what's the relationship between x to the k plus 1 and x to the k? One of them is multiplied by x. And that's how I would get to this next part, where we're just going to try and write down this thing that happens when you multiply by x. So this thing is ck x squared, and this thing is a k plus 1 plus b subscript k plus 1x plus c subscript k plus 1x squared versus, but also x times x to the k. So then plug these things together and try and do maths on them. Oh, we've now got this idea. Oh, we've written down a true statement. Oh, sorry, there's a button that does that. The horrible shaking thing. Damn, brilliant. It looks stupid, but it's a true statement, and we're going to try and work from there. Often when my students at university are stuck on a problem, they could make some progress just by writing down a true statement, even if it looks obvious. Just write down a true statement and then try and go somewhere with it. Here I want to do some substitution. I want to take these expressions that I had for xk and xk plus 1 and plug them in, and do maybe some comparing coefficients. Maybe I'll use the fact about x. I haven't used it yet in this part of the question. So yeah, I would just go for this as well. It does feel a bit like induction because we're relating together k plus 1 to k. If you know what induction is, this feels like induction. Feeling like induction kind of helps, I suppose, but not very much because you've still got to have the idea and you've still got to do the maths. Okay, so if we plug stuff in, things are not too bad. We've got a similar idea to before, actually, that the powers don't match up at all. There's an x cubed on the right hand side, but we know about x cubed. We know a fact from the top of the question. So I can use that to replace this one. The c's contribute to the other terms, and the coefficients match up. Yeah, so there's a question in chat from Jay that's pretty good, actually. The question is, how does this work for k less than 4? Or k equals 3, right? Jay actually asks about 0 and 1 and 2. It does work. Let me show you why. First we're kind of, I'm abandoning the algebra here. I reckon everyone can now plug in the x cubed thing, rearrange it, compare some stuff, say it's equal. The fact that we're given up there, we're told that this is, we can uniquely write this power like that. So we actually already saw right at the top of the question that x cubed is equal to 2x plus 1. So that looks to me like a3, the constant in that expression is 1, b3 is equal to 2, and c3 is equal to 0. So maybe I misspoke when I said a quadratic, because maybe that c could be a 0, in which case that's a linear function, not a quadratic. But we can write it in that form, with c3 equal to 0. Separately, I think the question in chat is, could you write these ones in the same format? The question is this, and the answer is I can write those in the format at the top of the screen there. It's a bit stupid. Once I've written down that one, you can probably see what I'm doing. 1 times the relevant thing, right? So 1, which is x to the 0, is in the format of 1 plus nothing, which is a0 equals 1, b0 equals 0, c0 equals 0, and then up here a1 is 0, b1 is 1, c1 is 0. These ones are not very exciting. They're kind of not in the question. They're not really mentioned in the question, and they're not very interesting to work out or talk about really, but there they are. Someone in chat was talking about matrices, actually for the previous question, but if you've met matrices, then what's going on here? Good. Conrad wants to know about the series AK, BK, CK. Pretty good. That is the rest of the question, because the rest of the question wants us to play tricks with these things to show that we've done that bit at the top. We've now got some relationships, and it starts asking us about this combination of the terms. We're going to get close to solving for them. We're not actually going to solve for them in this question, which is perhaps frustrating, but we're going to solve for this dk thing here. We are going to work that out. We're asked to show that dk plus 1 is equal to d minus dk. I think the best way to do this is to interpret dk plus 1 as this thing. This dispels the mystery about what these D objects really are. It replacing them with things that we already had in the question. And even better, still at the top of the screen there, we've got some relationships between these things. So this is going to be fine. I'm not going to just substitute in and go with it. I'm also skipping this bit of algebra. Do you need to show that's fully answered the question? Let me have a quick check back up. Question is missing the for every integer k bigger than 0. I would, to be honest, I would not do any of this in my attempt for the question. I don't think it's important. All this. The thing that we've done, this trick of multiplying by x, this true statement is true even if k equals 0, which is a bit daft, but everything we do after that actually just works. Some of the stuff is 0 on the way through, but actually still a true statement, even if k equals 0. Like the steps we're following are just fine. So it would be hard for somebody to criticize our solution and say, oh, you missed out k equals 0, because we really didn't. We didn't explicitly say what the numbers were, but we have this the relationship. So the relationship we're proving is true by the same method. So I probably wouldn't work out these numbers. I did because I am a bit interested in these numbers. They're kind of pretty. It's just nice. And also somebody in chat asked nicely. Good, right. Okay. I was just bailing out of doing this algebra for the dk plus 1. Big reveal is that these things are almost the same thing with a minus sign in, and it's return of our old friend minus 1 to the power of k, which is, it just gets an extra factor of minus 1. dk is equal to this. Technically we should check that it's not this thing multiplied by 17 or something. That would also satisfy an extra minus sign every time you change k. But we know the value of dk. We have some examples, so we could work out, for example, d4 is 1. So we can check that it's that way around, that it's not secretly that times 2 or something. Skipping this because minus signs are not super exciting. Rearrange that thing. There is a final part of the question. This question is worth 15 marks in total. That's how long math questions are worth. 15 marks is quite a few for what we're doing. You get marks along the way. Even if you don't finish part of the question, you can still have some marks for your working out, as long as it's not wrong. I made that sound too generous, right? Okay, last part of the question wants us to define a new thing again. Sometimes it's stressful getting new things thrown at you, but actually this thing's defined in terms of previous objects. I have basically no idea why it's defined in terms of the k plus 1 variables instead of the k variables. I don't think anything goes wrong if they defined fk to be ak plus ck. I don't know why. I don't know why you would do that. But hey, that's how they've done it in the question. We've been asked to show that something really nice. My plan is to show that, to treat it as if it says equals a k plus 3 plus c k plus 3, and then to reuse those relationships that we had before, the things that relate together the a values with different subscripts on them, to desperately apply those to try and get all the subsets to match up. Negative number to a power, time to think about odds and evens. It's good advice from chat. Thank you, anonymous person who posted that. Okay, so my plan here is to work this. There are actually two ways to work this. Let's finish off this question. I'm sort of taking all of the interesting bits and leaving some of the algebra for you at home. If you're trying this on paper or something, then you've probably got more marks than me for actually doing the question, right? If you want to see the solution, there is a detailed solution posted at the MAT Live website. That's my excuse for saying there's two ways to do this. One way is to start with the the biggest subscripts you can see and try to reduce them. We've got these facts at the top of the screen there. We've got some facts that say if you see an A with a large subscript, a B with a large subscript, or a C with a large subscript, then you can replace that with a slightly smaller subscript. So A k plus 3, for example, that's equal to C k plus 2, because that rule on the left says that I can take the A subscript and write it as C with subscript 1 fewer. So I can start using that to rearrange that. That says, brilliant news. This term over here, this CK plus 2, is actually equal to this AK plus 3. Great stuff. That's kind of progress, right? Comparing the terms of, those ones are equal. 2 problems down, 4 problems to go, right? So maybe I could just work with that CK. This is BK plus 2, but I don't have a BK plus 2 on the left. I have this whole mess of terms on the left. So I could keep working, right? What's BK plus 2? What's AK plus 2? Can I turn those into K plus 1 kind of things? And if you follow it through, then you can match everything up. Second approach is to say, actually, I want to increase the subscripts. If I look at the right-hand sides of those equations at the top of the screen, they tell me a way to increase subscripts. So if you start from the right-hand side, it says whenever you see a CK, you can replace that with an AK plus 2. Sorry, whenever you see a CK, you can replace it with an AK plus 1. You can read it right to left to say, that the subscript is increasing. Or I'm getting left and right mixed up, and I'm getting powers and subscripts mixed up. Almost there. That's a bit like arguing from this end and saying, this one over here, this is equal to a k plus 2, which is, well, it's equal to this one over here. So now I've got a whole bunch of a's on the left, and I've got c on the right side. Maybe I can match those things up. Goodness me. I've still got an AK plus 1 over here. The strategy of increasing the a's is a bit awkward now, isn't it? Because none of the things have got a on the right hand side. What am I going to do? It'll work out. I prefer the reduction strategy because reading those equations left to right is, I guess, because I read left to right, I suppose, and I like reducing problems to smaller problems. I guess they're not actually smaller problems, they're just problems with smaller subscripts, but it's the direction I like to go in, I guess. Both options are available. Also, not shown on the screen here, but also we could use this D fact. Doesn't seem completely stupid. It's got an A plus C in it. A plus C is the thing we're now interested in. That's got to have some relationship, right? We literally just proved that it's B plus minus 1 to the power of K. Maybe we should use that. So not a terrible idea is to show that, to treat this show that question as a show that B k plus 1 plus minus 1 to the k plus 1 plus b k plus 2 plus minus 1 to the k plus 2 is equal to b k plus 3. I think it's this many. Yep, plus minus 1 to the k plus 3. If that was your intuition to reuse the last part of the previous part of the question, then hooray! But you're probably feeling quite clever because these minus 1s cancel. And then you've got to do some subscript rearranging and to do the same sort of tricks that we were just talking about. Okay, either way, try and bash these things together, compare terms, use the rules at the top of the screen there as much as you can to try and relate these things together. Extension question is, what's going on? Please could you solve this cubic up the top and let me know what values of x we're actually talking about. Because we're only actually, in all of this complicated stuff that feels a little bit like matrix theory down here and feels a bit like cubics up here, in all of this we're just talking about 3 values of x. We could solve for those by solving that cubic. Not an impossible task. Can anyone in chat tell me a root of that cubic? Can you spot a number that does that? I don't know, I suppose if you've already read the solution notes or something. Jay wants to know what percentage of math questions are show that. I'd say that it varies quite a lot, but sometimes about 20% is show that. That's a rough guess. There's quite a lot of calculation. Some questions are almost entirely show that, and some of them are not at all. 20-30% maybe. Guesses in chat for 1 and minus 1, let's check both. If I plug in 1, then on the left I get 1, and on the right I'm afraid I get 3. If I plug in minus 1, there's a couple of people have noticed that in chat, then I get minus 1 on the left, and I get minus 1 on the right. Hooray, we found a solution. Minus 1 works. If that was the only solution, then this question becomes really easy because you can replace all of the x's with minus 1s. And the show that question would be show that 1 is equal to minus 1 plus 2 times 1. Oh yeah, that's true. Show that minus 1 to the 5 is 2 take away 4 plus 1. Yeah, it's true as well. Next part. There's a couple of other solutions for x though. So it's not just a question. It's not just a complicated question about the number minus 1. I think I'll leave that mystery as an extension to look into. That is how the show works, I think. If you want more detailed solutions, especially for that long question at the end, if you want more detailed solutions, those are posted on the MAT Live website. But I think we're out of time, so we're going to call it there. If anybody's got any quick questions, I said Q&A. Feels like we're not going to get very much Q&A done today. There is also an email address you can contact us on. We're going to be live every Thursday, trying to check the comments underneath this YouTube video, also checking our emails. You can email us on undergraduate.admissions@maths.ox.ac.uk. Next week, we are covering algebra in general. We'll be solving simultaneous equations. We'll be looking at the binomial theorem. We'll be multiplying out brackets, and we'll be trying to avoid multiplying out brackets. We've got a question with a parabola coming up, a little bit of geometry, algebra, crossover stuff, that lovely space of geometry and algebra at the same time. Jay has, in chat, I'll tell Jay you're correct, it's not on screen, but the number you've put in chat is correct. Right, good, okay. People who have seen any of my live streams before will know that I have no idea how to stop them. I think I have to press that button and then also this one. I will see you next week for another episode of the Oxford MAT Livestream. Remember the name of the show that I'm currently on. Oh, 2 hours, eh? That's quite a lot of hours. Thanks for joining in chat. See you around. Bye.